Welcome, everyone. We're going to be talking today about a theme called Observability by Design. I'm Josh Suereth. I'm one of the technical leads in Google Cloud focused on instrumentation and telemetry collection.
I am Laurent Querel, F5 staff engineer.
And so we want to kind of talk about a theme that we've seen frequently, which is basically, have any of you experienced one of these situations? Raise your hand if you've experienced one, and just keep holding it. But basically, have you deployed an update that breaks all your alerts and dashboards? Okay. Have you had to write overly complex queries? For example, someone named the HTTP request duration slightly different than someone else, so you have to OR it together, right? Are teams struggling to understand what metrics you have available at all to alert on, right? And then last, have you lost time in prod because you have missing or incomplete instrumentation that you thought existed, but when you go to diagnose the problem, you can't figure out what's wrong? Okay, so we want to propose a new way of thinking about observability. This comes from, if you know the original term of observability was about signal systems, where you try to take and learn the internal state of a system via publicly available signals, right? What's the important point in that is that publicly available means observability is a public API, and you actually need to treat it like you would a public API. You need to treat it with the same kind of quality bars and its own observability to understand if it's working, right? So that we're going to talk about some tools and things that we can do to make that happen.
Okay, so we want to fix that with some tooling and some automation. So we are introducing a concept of observability by design. It's the same idea that you can find with privacy by design or security by design. So it's basically integrating your observability workflow directly into the software development lifecycle. So here we have a summary of what is this workflow. So first we start by defining clear goals. We basically ask various people from developer, SREs, and product manager to define the most important signals that they want to see into the product in order to manage it, to operate it. Then we want to introduce a lot of automation that currently does not really exist, except for unit tests and integration tests that you have already into your application, but regarding observability by itself, it's not very common. So what we want to do is to make sure that you have a set of automation to generate documentation and keep this documentation always in sync with your specification. We want to give you a set of solutions to create client SDKs that are purposely built for your system. Exactly like with gRPC, where you can generate client and server stubs, and you just integrate that into your application. We want to do the same thing with observability. And we also want to give you some ways to make sure that every time you change something, you are able to create some kind of delta, some kind of diff, and make sure that you have policies to check that it's compatible, to check that it's properly documented. And we want to iterate. So the iteration will be, okay, we want to make sure that we learn from any production issue, but we also want to make sure that every iteration will be secure. And that's the diff system that we introduced recently in the tool that we will present, that is named OpenTelemetry Weaver.
So we're going to walk through each of these stages and kind of talk through some things we have. First, we're going to talk about definitions. Inside of OpenTelemetry, some of you may have heard about semantic conventions. Semantic conventions is an open catalog of basically expert groups that take a particular aspect of observability, and we try to create what we call T-shaped definitions. The T is, there's a broad set of simple definitions, like here's how you would monitor HTTP servers, and then there might be a T, which is a deep set of definitions of here's how I monitor like the Go runtime, right? So we have both of these in semantic conventions. There's a lot of special interest groups defining these things, and these are defined currently today in this YAML format you see up here, right? So there's a YAML format that says I have a metric. That metric has a name. It is an up-down counter in OpenTelemetry. It has a unit of this, and here's the set of attributes on it. We are automatically generating documentation for semantic conventions and stuff using Weaver. We'll talk about that in a bit. But the idea here is you in your corporation should have a very lightweight way, of just saying, cool, I have metric A, I have metric B, I have metric C. I want to define those and say what they are, and treat them kind of like an API, or like, as Laurent says, a gRPC kind of stub definition, right? Here's the metric I have. I'm going to produce this. Easy way to write that down, and then we're going to do more with it from that. Cool.
Yeah. So just on the OpenTelemetry Semantic Convention registry that we already have, where we have these 9 special interest groups that are working on. Right now, this registry represents 900 attributes with 74 domains. So it's already something that is really useful and that you can reuse in your project. So now, this Hotel Weaver, OpenTelemetry Weaver, it's a CLI tool available as a Docker image that you can integrate directly into your CI/CD pipeline. And you can do many things with it. And it's also a very open product, extensible product. So the first thing is to basically generate documentation that will be always in sync with what you have into your system. So let's say we have this registry defining signals, and we can generate from that a markdown documentation. So that will be super useful for people that want to basically create dashboard, or they want to leverage the signal that are generated in order to do some kind of machine learning system. So that's the first thing we have. And here you have a representation of this markdown documentation that is generated by Weaver for this OpenTelemetry Semantic Convention registry.
We're going to do a live demo in a second, but we're also going to talk about the other thing Weaver does, which is code gen.
Code generation. So code generation comes with 2 types of code generation. So the one that is currently used by most of the client SDKs inside OpenTelemetry is the semantic convention constant. So basically, the idea is to use some language construct to represent a metric name, to represent an attribute name. So it's relatively basic, super open, and we already have that integrated for each of the supported client SDK. But now we are thinking about another way, what we name type-safe client SDK, and Josh will present an example of that.
Yeah, so here's an example definition of a metric in Weaver. We're defining a metric. Actually, hold on, we were demoing in our before, so we don't want it to fail. So this is defining a metric called auction bid count. The example application we have, and we'll give you, it's github.com, Suereth, Ali by design, is supposed to be like an auction server for like eBay. So this is the little microservice that actually takes auctions and bids, and we're like, okay, let's keep track of how many bids are happening, right? So we define auction bid count. We want this to be a stable metric for our alerting system to say, hey, it's stability, which this system will track. The brief is the description that will be in the documentation, or maybe in the dashboard. You can get into a hover over that says, here's the name. The instrument is the OpenTelemetry instrument. In OpenTelemetry, we have gauges, we have counters, we have histograms, and there's more, but we'll just cover those for now. The unit is, and this is an OpenTelemetry convention, we use this UCM, Universal Standard for Measurement, so it is a bid, it's a count of bids, that's what the little brackets mean. And then we have a set of attributes, right? And if I say make, generate, go, it's going to generate my go code for me from this definition. Just to prove that we're going to change this, count of bids we've seen, I'm just going to add @KubeCon. And then I'm going to run make, generate, go, and I'll show you the code it generates. So this will automatically generate this observability package. And in the observability package, it creates an API. I want to give a shout out, thanks to Tyler Yan for helping me make this a little bit nicer. But anyway, inside of here, you'll see we're constructing type-safe wrappers to construct an auction bid count thing. And you see it actually auto-generates the code based on our definition. What this looks like in practice when we instrument is inside of our auction bid count, we have a handler that will handle, sorry, got to scroll up a little bit. that will handle bids, okay? And when we handle our bids, we have this nice give me a new auction bid count counter method that we auto-generated, so I can't mess up the names or anything, right? It's kind of hard-coded and type-safe. And then when I record that bid, I just say bid, add, and then I put the identities in here. And if I hover over, it should show me the documentation for the names that I use for my metric attribute, right? Because it's all code-generated. So this alleviates some of the friction of making sure that your metric definition is consistent because I'm doing something in a type-safe way. We're going to come back to this in a little bit.
Yeah. So just to complete that, so the fact that it's generating basically a library will be automatically be used by an IDE to implement smart completion. And it's a very nice way to discover for a developer what we currently have. We can just type HTTP, and then we will get all the HTTP metrics or HTTP-related attributes. That's really cool. Okay, so the next phase is to make sure that what we are doing is controlled with some kind of policies. And there are currently two types of control that we are implementing with Weaver. The first one is a policy-based static validation check. So for that we are using Rego. It's a policy language currently supported by the Open Policy Agent. And we are reusing this language inside Weaver to control basically everything. So from the naming conventions to making sure that every schema evolution are currently following the schema evolution rules. The second check is something on which we are working on currently. It's named Live Instrumentation Check. And the goal is to use your test, your integration test. From there, you generate some kind of telemetry streams, and we put Weaver in front of that, and we collect all the telemetry object. And we try to make sure that it's compliant with the registry that you define. So it's like some kind of coverage. We want to make sure that, let's say you generate the right amount of unit tests that will represent maybe 70% of the telemetry object that should be generated by your application.
Yeah, so for those of you that set up like integration tests and mocks, the idea behind the live instrumentation check is in my integration test system, I can create like I can take the server that's instrumented, I can make an OTLP endpoint that Weaver has that I will fire my collector into, or I will fire the SDK into, and Weaver will validate that the shape I said the metric is matches the shape that it receives. So you don't have to hook up an entire database and query that database and look at it there. You can actually have a much smaller integration component. That is coming to Weaver soon with live instrumentation checks, but let's look at policies a little bit. So if we go back to that metric definition, which, apologies, at this Zoom level, I will have to do it the lazy way. If we come back here, and let's say someone's making a change, and let's pretend they accidentally delete an attribute, right? But that attribute's used in my alerts, and I will break. If I run this make check command, which will show is under the scenes running Weaver on my behalf, you'll see that it fails, and you'll see it gives me a backwards compatibility error. That backwards compatibility error was defined in that language called Rego. We're using the Open Policy Agent language to do our policy checks in Rego. In Weaver, it matches kind of the Kubernetes ecosystem a bit. You can customize these policies to what you need. You can also copy what we've done in Semantic Conventions, which is this, to make sure that we, from version to version, are not breaking dashboards, breaking users, breaking everything. So you see here it says you actually can't change the required attributes of a metric because that's required. That is used in my alert rules. I will not allow that to be dropped. Anyway, these are fully customizable. Even the name of the message, the types and all that, you can actually configure these as you need. And there's some that we can give you out of the box. Okay, so next, deploy. This one's fun. One of the things that's coming soon is we want the ability for you to publish your definitions from a local project so other people can consume them and make use of them. including like database engines and things. So the idea would be, after I've defined this metric, or I've defined a span or an event, right, I can publish it in an open format that other people can see that definition and make use of it, including what we're calling our diff feature, right? So I want to give a shout out. On Thursday, there'll be a talk at 1500 on how to rename metrics without impacting someone's observability. This is a coordination we've been doing with the Prometheus group, where you could publish the differences in metrics, right? And then you can issue a query that will actually dynamically adapt to the different versions of metrics in the database. So instead of actually live migrating your metrics and saying, okay, I have metric A, I want to move to metric B, I will publish both. I'll eventually move my alerts from A to B once all of the A's disappear. We can actually tell the database, here's the change that happened. You adapt at query time. And that's a very exciting possible future that's coming. So again, there's a demo of this on Thursday. I would take a look at that talk. This is one of the directions we want to take Weaver, and we think it's very exciting. For now, the diff feature is available in Weaver, but we have some work to do to make it useful in backends. Anything else you want to add?
No.
Okay. So just to recap, we talked about kind of 3 stages of the software development lifecycle.
Yeah, so first we have those automation. So we can generate documentation, and you see the type of command, Weaver registry generate. You provide the registry, and you provide the template directory. That's, and the template directory is basically based on Jinja, so we are introducing, in fact, we are integrating mini Jinja into Weaver. So we have this generate client SDK, we have this check command, and finally the diff.
Yeah, so validate is this check command that runs that, basically a version of the OPA policy agent or the Rego engine. And then generate registry diff was that idea that you can iterate. So you can change your metrics, you can keep your production live, you can describe what those changes were to downstream systems that need to consume them and adapt to them.
Yeah, we have few other commands. One of them is registry emit. It's an interesting one. So basically, we use the specification as a support to understand, to generate fake data. So in this registry, we have a description, we have the metric type and so on, but we also have a set of examples. So we are using those examples to generate stream of OpenTelemetry object based on those examples. And that could be super interesting when you have to design, let's say, a dashboard, even if the system that you are instrumenting is not already there.
So yeah, future directions for OpenTelemetry Weaver. A few of the things we're thinking about, this notion of automatic schema evolution. Again, I'm going to call out to that talk in Prometheus. This is the thing we're looking at. There's a few vendors that are also investigating this with us. The second would be kind of easier registry sharing. This is something Laurent's been kind of pushing directly.
Yes. So the idea is to let vendors, enterprises define their own semantic convention registry and reuse the OpenTelemetry Semantic Convention when they need. So the goal is to reuse the same tooling to implement your own custom registry. And the idea also is to let people define some ecosystem. So if, for example, for F5 Network, we want to generate a catalog of telemetry objects from Nginx, we will publish that in this format.
Yeah. The next thing is actually out-of-the-box documentation code generation. Weaver today is kind of the foundation behind semantic conventions and instrumentation in the OpenTelemetry ecosystem. Any stable OpenTelemetry instrumentation is based on stable semantic conventions in OpenTelemetry. Weaver's the tool we use to provide that stability, to provide those guarantees across a rich range of very complicated space, right? Like all of those languages. What we want to do is actually take that complexity and kind of remove the complexity so you get a simple thing that you can consume using the Weaver engine with out-of-the-box defaults that are appropriate and much simpler for easy adoption. Again, we want to make it as easy as like defining a gRPC endpoint. Should be how easy it is to define, here's a span, here's a metric, here's an event, and I want to publish this, right? That should be the easiness that it gets to. That's a future direction we're taking it. So if you look at the tool now, it's going to be a little complicated because it's designed for OpenTelemetry. This out-of-the-box stuff is kind of the next effort. And lastly, we're looking at native integration with observability tools and data catalogs. Now, I think that's the end of our time, so we just want to call out a few GitHub repo links if you want to take a look. That demo is the observability by design. If you want to see how we define policies, how we define code gen, how we set up the makefile to do both Go and Rust, depending on what you're interested in. And then OpenTelemetry Weaver has a whole set of docs on how to get started, how to do all of these policies, how to do the code gen, what the different tools are. If you're interested in getting involved, let us know. We're always looking for help. We're always looking for contributions. But hopefully you appreciate this vision. I'd like to open for questions if we have time. Do we have time, Austin? Okay. We have some time for questions. If anyone's interested, feel free.
So you talked about live instrumentation checks and how like the instrumentation maintainer would use them for the compliance tests. Thinking this a step further, as the ops person on the observability vendor backend, would you see any value in having something like that run there as well, where it would like reject metrics or generate warnings if it's not compliant, even before you do any queries on it, just so you see that you don't mess up your database or something?
Yes. So I will say that like internally for Google Cloud, we actually do this. We have, so if you look at Google Cloud, we have like a metric descriptions for all of the metrics that Google Cloud produces that people can consume, and we actually do have a system that does that. So that is a direction that I think that we would like to provide via this kind of tool. And it all starts from having that definition. Like you have to have a definition to do that enforcement. So when we have that definition, we can expose it. That is absolutely a direction we'd like to go.
Yeah, and we are also introducing the concept of annotation inside the semantic convention. So that's another way to extend the data model, in fact. So if you want to create some kind of tooling to define relationship between things, or if you want to specify the sensitivity of a specific attribute, that's a way you can basically extend the data model.
Yep. Thank you. Good question. I think there was another question up front. Do you mind going to the mic? Yeah.
First of all, thank you. And are there any languages supported other than Go and Rust for the client SDK generation? And is there any plan on roadmaps or?
Yeah, so right now, most of the code generation is focused on OpenTelemetry itself. And in terms of languages supported, Java, JavaScript, Rust, Go. I'm trying to remember what's
Python.
missing. Python, I think. There's a slew of like 6 or 7. C# works.
Yeah.
In terms of the client SDK type safe API, that is work that is kind of actively starting. So if you're interested in working on that at all, let us know. Otherwise, I'd say that roadmap is probably in the next 6 months.
Yeah.
Okay, thanks.